Okay, so today, yay, it's June 6/1/18. Hooray. So, Tamley, you need to pay attention because this is what you missed yesterday. So a piecewise graph is really two or more graphs pieced together. So a piecewise graph is really two or more graphs pieced together. So we have two graphs here. We have equation 1, which is going to be y equals x plus 3, and we have equation 2, which is going to be y equals 2x plus 3. Now, since they are two graphs pieced together, what I like to do is find out where they're actually attached. So they're attached right at x is greater than 0 or x is less than 0. So they're going to be attached right at x equals 0. Now this is an invisible line. It's an invisible line I'm going to put at 0. So what I'm going to do with that then is I'm going to just simply graph this. I'm going to start, y equals, so I go 1, 2, 3, and I'm going to go up 1, over 1, up 1, over 1, up 1, over 1, okay? And I'm only going to graph this part of this graph. This part back here will not graph because it says this, my first graph, my y equals x plus 3, is only going to be greater than or equal to 0. So that I'm only going to graph that part of it, not the negative part, okay? Then the second graph, which starts at 3, is going to go up 2 over 1, up 2 over 1, but I'm not going to graph it over here. I want it to be less than 0, so it's really going to be this graph here. The two are connected right at 3. So it's a piecewise graph because there's two pieces to it, okay? So what we want to do now is translate. We're going to translate it 4 units to the right and 2 units up. So what I think I'm going to do to make this easy for myself is I'll just translate the point that they're connected, okay? So we take and we're going to move it over 1, 2, 3, 4, and up 1, 2. So I've just translated this point to here, okay? I've moved it over 4. Now we're going to go ahead and just redraw the graph, which is going to be up 1 over 1, up 1 over, so we're going to have this graph here, and then this graph here. Okay, that's not too bad. Now, find the new equations for both. Okay, now, Natalie, this is where you're going to see when I do the dance. Here comes the dance. So let's take our equation 1. So our equation 1 is our y equals x plus 3, right? But if I want to take it 4 units to the right, I'm going to write this as y equals x. Now, to the right is going to be a minus 4 plus 3, but then I also took it 2 units up, plus 2. So my translation, let me put this in a different color for you. My translation is my minus 4 and my plus 2. Okay? So anytime I move things horizontally, okay, ready? This is the dance, right? Anytime I move anything horizontally, I'll have to do it within the x in the equation. But it's the opposite way. So I said I'm going to go 4 units to the right. You think that's a plus 4, right? But it's actually in the equation, it's going to be the opposite. It'll be a minus 4. So, and I do this little dance because as I'm moving to my right, you see me going the opposite direction, right? And I always dance horizontally. So that you'll remember that anytime you do a horizontal shift, it's within the parentheses and it's the opposite, okay? Now I could simplify this, right? I could rewrite this as really a y equals an x. Let's see, that would be a plus 1. Okay, you guys agree with that? If I just simplified this, if I take the other equation, the second equation, I'll do the same thing. I'll go y equals 2, and I'm going to do the dance, which means I'm going to take this and translate it 4 units to the right. So I'm going to go an x minus 4 here, plus 3, but then plus 2. So I'm going to do both. So I shifted the second graph to the right 4, and I shifted the second graph up 2. So my translation opposite inside. Now I can simplify that too. That's simply going to be a y equals, let's see, that's a 2x. Let's see, I get a 2x minus 8 plus 5, which would be a minus 3, okay? I just simplified that. Right? So So here's my new equation. So I'm going to say f of x equals, we need the big brace because it holds both equations, right? I've got equation 1, which is now my x plus 1. That's this one here, right? And I have my second equation, which is my 2x minus 3. But they're connected in a different spot, aren't they? In fact, they're connected 4 units to the right. So they're connected now, not here at 0, but they're connected at 4, aren't they? So the first graph, we're going to say, we're going to go x has to be greater than or equal to 4. Oh, and the second equation, x is less than 4. So what we did is we took a piecewise graph and we moved it. But we also have to move its boundary line, right? We have to move where it's connected because the connecting line also graphed. So it's pretty easy to see. The equations aren't as easy, okay? Let's look at example 2. Does that help? Okay with that? Okay, example 2. So it is a parabola, and I'm going to go ahead and graph my parabola. I'm going to go start at negative 4, 1, 2, 3, 4. And I'm going to go 1, 1, 2, 1, 2, 3, 4, and I'll go 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, and so forth. I also know that negative 1 squared is a positive 1, negative 2 squared is a positive 4, negative 3 squared is a positive 9, okay? Let's go ahead and draw it in. So here's my parabola, okay? So identify the x and y axis, x and y intercepts. Well, from the graph, my x-intercepts are at x equals 2 and x equals negative 2, right? And then from my graph, my y-intercept is simply at 0, negative 4, right? Two, 0, negative 2, 0. Here, let me erase that. All right, circle that. Circle that. Now I got that from the graph. What if we can't figure it out from the graph? Well, we'll go and do the math. The math is this. To find an x-intercept, let y equal 0. To find a y-intercept, let x equal 0. Okay, so instead of just looking at it, because the graph is easy, I can say, well, it's there, and it's there. But if you don't have, you know, your graph, you could still find it. So if I wanted to find my x-intercepts from here, if y equals 0, f of x and y are the same thing, I'd have 0 equals x squared minus 4, right? And if you solve for x, bring it over, 4 equals x squared. How many answers? 2. So if I take the square root, that's where I get my plus or minus 2, right? Plus or minus 2. So that's how you can do it using math instead of just the graph. Now, how do you get the y-intercept? You let x equals 0. So if I take my y equals 0 squared minus 4, well, that's pretty easy, right? I'm letting my x value be 0. Well, that's easy. That's just y equals negative 4, which is what I already had. Okay. Now, that's nice to know because in the next example, you're not going to be able to get it from the graph. Okay. Now, graph 2f of x. To be 2f of x, you're going to have this graph be twice as tall. Okay. So 2fx, you're going to make the graph twice as tall. Let me graph that. Let me graph it in a different color. Okay. So twice as tall. So instead of 1, 1, it's going to be 1, 2. Okay. Actually, I think it starts all the way down at negative 8 also. Oh, I do. It's going to be way down at negative 8. I made a mistake. 1, 2, 3, 4, 5, 6, 7, 8. Because we go 2 times our x squared minus 4, which is y is equal to 2x squared minus 8. Okay, sorry, this point shouldn't be there. Where's my whiteout? There it is. Okay. So, twice as tall, instead of 1, 1, I'm going to go 1, 2. Instead of 2, 4, I'm going to go 2, twice as tall. So 2, 4, twice as tall, 2 1, 2, 3, 4, 5, 6, 7, 8, okay? Same thing here, 1, 2, and 2, 8, okay? Okay, here's my parabola. It's been multiplied by 2, okay? I made it twice as big. I wanted 2 times the function, so I multiplied the function times 2 and got a 2x squared minus 8. I graphed that. I went down to negative 8. Twice as tall. Instead of 1, 1, I went 1, 2. Twice as tall. Instead of 2, 4, I went 2, 8. Now, again, my intercepts, my X-Intercepts, we can see them. They're here and here. Same spot, right? So X-Intercepts are still at negative 2, 0, and 2, 0. And my Y-Intercept, we can see it. It's all the way down here at negative 8. Y-Intercept is at 0, negative 8. Okay, that's pretty easy, right? We can get that from the graph itself. Okay, now, how do you do it without graphing? Well, we're going to go back to the fact, highlight it. We'll let y equal 0, and then we're going to let x equal 0. And we get the intercepts by simply solving, okay? So first, let's figure out what the x-intercepts are. So I'm going to go 0 equals a 2x squared minus 8, right? And if I want to solve that, I'll go plus 8 plus 8. Divide by 2. And then square root. Square root, we know there's 2 answers, plus or minus 2, which we had from the graph, right? If I want the y-intercept, I let x equal 0, so I want y, my y-intercepts. I'll take my y equals 2 times 0 squared minus 8, but obviously that's going to be negative 8, right? Does this seem pretty easy? Okay, good. And that concurs with our graph, right? Okay. Oh, look at that. Darn it, bleeding. Took a nasty fall this last weekend. It was fun, though. Went head over heels, mountain biking.
Literally?
Literally.
What, you're bleeding?
Yeah, I took a good fall. I got my back's all scraped up, too, and yeah, it was a good fall. Anybody mountain bike? Yeah. Jacob, you'll love it. There's a root about the size of this, about that shape. My front tire hit, I couldn't see it. Bounced me up, came back down like that. Bam, hit hard. Anyway, turn the page. Okay, now, example 3. A college charges different fees according to the number of credit hours students enroll in. Okay, the scale fee is 110x from 0 to 12 credits, 1,320 from 12 to 18 credits, and then they've got this weird function, 150 times x minus 18 plus 1320 if x is greater than 18. So first of all, graph the function. So what I have, again, it's a piecewise graph. Before I do anything, I like to put the border points in first. Okay, we've done that before. So I'm going to put my imaginary lines at 0, at 12, at 18, okay? These are invisible lines, and this is where the graphs are connected. Does that make sense? Or maybe they aren't even connected, but these were all 3 pieces of the graph happen to be. So I know I'm going to have the first graph between 0 and 12, the second graph is between 12 and 18, and the third graph is between from 18 over. Okay, now let's graph these. So first one, graph 1, right? Graph 1 is y equals 110x, okay? So I do know that if I take 0 credits, it costs me $0, right? Watching? So to make this easy, so trying to figure out up 110 over 1, up 110 over 1, let's just plug in 12, okay? Let x equal 12, and then I'll get this point, I'll connect them, because we know it's straight. Does that make sense? Much easier, okay? So let me use my calculator. 110 times 12 should be 1,200, right? Okay, 132, clear. 110 times 12, I get 1320. So let's go up to 13, so that is 1,200. 1,320 is it's about there, okay? So I'm going to draw my graph in here. Now, Katie's ahead of me. Thanks, Katie. I'm going to make this an open circle because there's no equal sign, and I'm going to make that an open circle. Thank you, Katie. And I'm going to draw in my line. It is linear, okay? So draw my line. Okay, there it is, right? Erase to make sure I have open circles. All right, now the second function, that's easy, 1320, right? So equation 2 is just y equals 1320, which is straight across 1320, right? So closed circle on that one, which connects it, and closed circle here. So I'm just going to go straight across on that one, and I will need a ruler. Here it is. Okay, straight across, 1320. Okay. Closed circle, okay. Now the last graph is this one here, okay, number 3. And I've got 150 times x minus 18 plus 1320, okay? Now, what I might do to make this easy to graph is let's plug in, let's let x equal 18, and how about 24? And let's let x equal 24. So if we get 2 points, we can just connect the dots, right? Make sense? So let me plug in 18 first. 18 into here is 150 times 18 minus 18 plus 1320. Well, that's easy. That's going to be 0. That's going to be 1320, okay? So I'll have a dot at 1320. Okay, good. Let me plug in 24. If I get 2 points, I can just connect them, correct? So I'll plug my 24, 150 times 24 minus 18 plus 1320, and I'm going to use my calculator to get my answer. It's a lot easier if I let my calculator do the work, right? 150 parentheses 24 minus 18 plus 1320. I get 2,220. 2,220. So here's 2,220 is about there, okay? Okay, there's my piecewise graph. How am I doing? Now, like everything, like inflation, the next year they're going to increase inflation. They're going to increase the fee by 10%. So we're going to increase the fee by 10%, right? So what we're going to do to make this work for us is we can multiply all of these equations by 1 point. So if it increases by 10, we're going to multiply by 1.10. 10% increase plus the original amount. That's why I need the 1 here. Here's my 10% increase. We need the 1 here for our original amount, right? So I'm going to take equation 1. Okay, equation 1, which is my 110x. I'm going to multiply that by 1.10. All right, let's see what that is. And I get an answer for 121. So my equation 1 now is y equals 121x. My equation 2, which is simply just a y equals a 1320, I'm going to multiply that by a 1.10 because that'll increase it by that much. So 1320 times my 1.10, and I get an answer of y equals 1452, right? And then my equation 3, I will take and increase it by, so I've got my y equals my 150 times my x minus 18 plus 1320. And I'm going to multiply the entire equation by 1.10, right? So when I do that, 150 times 1.10, I'm going to get 165 x minus 18 plus my 1452, right? All right, I'm getting close. Okay, sorry about that. Okay, I'm getting close. I've got new equation, I've got new equation, and I've got new equation, okay?
Where did you get the 165?
I went that times that. Got it? Now, if I need a new equation, it's going to be a big f of x, because it's a piecewise graph, right? Fx equals, okay, and we're going to have then 121x. We're going to have our 1452, and we're going to have our 165x minus 18 plus 1,452. Okay, now we got to put in our constraints, and I'm running out of room here. So you know what? I'm going to put it down here because I'm running out of room. F of x equals 121x, 1452, 165 times x minus 18 plus 1452. Now, here's the thing about tuition. How many credits are you going to take, right? So this one is if you're between 0 and 12, right? So that stays the same. They're not going to change the difference in credits. They're just going to up the price, right? You're going to, you can take 12 credits, great. And the same thing with this one, if between 12 and 18, they're not going to change that constraint, just the price. And then finally, the last one, same thing, and that's if x is greater than 18. Okay. Now, how do we graph this? It's actually pretty simple to graph, okay? Because we're going to take this number 1452 and make this work, okay? So, the 1452 is about, put it in red, let's see, that's 1452 is about here. So my new graph would be like right about there. Okay, 1452 would be right about there, and then this one would be right about there. There's my new tuition, 10% higher, and my new equation. There's my new equation. Okay. How's that? Okay. And we have oodles of time, you guys. Oodles of time. So, I have a homework assignment. I don't know if you're going to do it, but you should try. We have just a few days left. Try, right? Just try.